My name is Haley Dyer, and I'm the Marketing Director at BioSero. I'm going to be hosting the webinar today, keeping on top of any questions that flow in.
Thank you, Haley. Also, a warm welcome from my side. I'm Patrick Weindl. I'm product owner of the C.STATION, which is going to be the main topic today. Part of C.STATION since close to 2 years. Yeah, I'm very happy about the opportunity to talk today about the C.STATION and the convergence of the two BioCo subsidiaries, C.STATION and BioSero. So C.STATION is based in the beautiful town of Freiburg in Germany. Our whole portfolio is focused around cell line development with more than 200 customers globally trusting our products. We are offering a range of benchtop instruments, consumables, and reagents in the field of cell line development, and, well, eventually, since launch in 2022, also the C.STATION. So a bit of history around C.STATION. C.STATION was founded in 2014 as a spin-off of the Institute of Microsystems Engineering at the University of Freiburg, focusing on the unique technology, our core technology of single-cell dispensing, with the first product being the single-cell printer. In the past 9 years, the features of the products around this core technology were constantly improved, and the portfolio has since been expanded with complementary products to make CLD work easier. C.STATION's aim is to make laboratory processes more efficient and to bring therapies to patients faster, safer, and make them more affordable. C.STATION's newest product, launched in 2022, as I already mentioned, is the C.STATION, where we do not only automate individual pieces of the CLD workflow, but the whole workflow. And with this, I'd like to hand over to Dustin, giving you a brief introduction to BioSero.
Yeah, thank you, Patrick. Good morning, good afternoon, wherever you are in the world today. My name is Dustin Whitson. I'm an applications consulting scientist here at BioSero. So a little bit about us, what we do. BioSero develops science-centric software and laboratory automation solutions that really enable researchers to orchestrate their discoveries at every stage. Our Green Button Go software suite and the integration services we provide match laboratory automation to your science in the lab. So we have over 100 employees now. We've worked with over 750 customers around the world in 20 countries. We were founded in 2003 and have been a part of the BioCo family since 2021.
Yeah, already diving into the C.STATION. So I want to give you some background on the idea of the product, where it comes from, what the thought behind it is, and an overview of what it does entail. So as I already mentioned, the focus of C.STATION is streamlining CLD workflows. So we want to find solutions to challenges our customers face, which are on the upper part here. You can see key challenges in manual CLD workflows, where people might have difficulties assuring clonality, tracing data, managing the integrity of the data. Lots of Excel handling, to be honest. Also maintaining quality from start to finish of the whole workflow of the whole project, because these can be lengthy depending on the cell line. And then lastly, manual workflows are complex and time consuming. And then on the lower part here in dark blue and yellow, you can see challenges we see on top of these when you want to transfer your workflow from manual to automated, which means it can be complex and lengthy implementations, handling different devices, in-house automation and programming expertise is required, and there are high initial costs. Also, the realization of these projects is usually very complex, and then there is a big topic of service and support. Our answer to all these challenges is the C.STATION, which, as I already mentioned, fully automates a CLD workflow and is meant to be a turnkey solution. So the whole work cell is pre-configured with best-in-class instruments in different fields, incubators, liquid handling, and also software, where Green Button Go from BioSero comes in. And this enables us, as I said, not only automating cloning or other individual work steps of the cell line development workflow, but the whole workflow. It is a solution that both addresses the key challenges in manual workflows and automation integration. There is no need to know many different softwares, many different interfaces, knowing coding. It is ready to be operated after the installation without expert knowledge. And on top of that, we have a unique data management solution, which we will dive into in a little time, that ensures traceability and does support for FDA or EMA submissions. So I will start off with an overview of the systems architecture. Here on the left-hand side, you can see a condensed overview of the interior of the C.STATION, which is like the key devices we integrate. We're using a cytomets as incubators, can be static or shaken configurations. The core where the project starts is the upside single cell dispenser and imager, combined with Excite software. Then we use a PF400X sample handler and a Hamilton started liquid handler. All this is basically commanded by the Green Button Go scheduler, which also talks back to something we call CDS, Clonal Data Service, which is a service that's constantly pooling all generated data in the background. And with this, C.STATION doesn't start from scratch like a fully customized automation work cell, but it is always starting off of this basic architecture, and we configure it to the needs of each customer based on the application. One device I want to give a special mention is the upside. As I said, it's the core of each project because they start there. Clones get dispensed here. So it both is a single cell dispenser. You can see the three key features: single cell isolation efficiency, the probability of monoclonality, and the clone recovery there. But it is also an imager, which is used in the C.STATION to track cell growth, and additionally has automated analysis within the C.STATION to track, to see confluency, provide data for hit picking, and additionally enables users to measure titer for monoclonal antibody producing cell lines with the fQuant kit, which is also offered by Cytena. And then the other main piece of software we use in the C.STATION side of Green Button Go is C.Studio, which is a interface to the data pool within the C.STATION framework, where users always have a live view available of all the data generated from all the instruments in the work cell. So not only images can be viewed, but also clone transfer events, selecting clones is being done there, the analysis of the performance of individual clones happens in C.Studio. And on top of that, since everything's working together with the clonal data services, we ensure that all clones are correctly traced and clonality reports can be generated. What I want to mention additionally is in the C.STATION framework, we also support the import of any externally generated data. So in case you want to use a device for some sort of assay that is not featured in the C.STATION, this can be done externally and then re-imported to the C.STATION, so you can still choose your clones based on that data. The clone tracking and reporting, as said, it's all backed by the clonal data service, where all data always goes. And what this does enable is three key features. There's digital clonality reports as a PDF, ready to be signed and exported. There always is full traceability of individual clones, and this tracing does not only happen in the clonal data services, also Green Button Go, our like our extension of it, let's say, does also feature tracking of the clones, so everything's always like double safe, let's say. And this goes from single cell seeding to selection to actually when the clones eventually leave the C.STATION for bioreactors, for example. In the reports, those can include all the generated data, meaning images, parameters, plate IDs, and then also user-specific decisions, which would be, for example, hit pick parameters or titer thresholds. So I already mentioned two key parts here, let's say, like the clonal data services, C.Studio, which we use in the C.STATION framework to make the whole CLD workflow easier and, well, easier accessible in the end, paired with Green Button Go. So all of this in our thinking is an automation suite that's rethinking automation architecture, because we are not only talking to the devices, but we are constantly making sure that all data is pooled and connected, that all the data can be visualized at any time and is always accessible for a user, well, through C Studio. And additionally, with a piece we call C.STATION scheduling service, we want to reduce complexity because, as I already mentioned, usually there's many different softwares one has to know to make an automation workcell live. But in the C.STATION framework, it's basically only C Studio and GBG, and this is also enabled by the background services of the CDS and CSS. So here you can see an overview how everything works together. Makes it a little bit easier to understand. At the core, you can see the two pieces a user interacts with, which is Green Button Go and then C Studio. And here you can see how they are always interconnected. So in our automation suite, Green Button Go does mainly talk to our scheduling services. So they share plate data, they share instructions, they share project schedules. And then the scheduling service shares his information with the clonal data services, which are then displayed by C Studio. On the other side of things, Green Button Go takes care of all the commands, parameters, and everything that will be sent to individual devices, which would be Excite software for the upside single cell dispenser and imager, Venus for, in our case, for the Hamilton liquid handler, and then, well, all the other devices that do not necessarily generate data. But all results are always circled back into the automation suite. Oh yeah, actually with this, I already hand over to Dustin, sorry.
No worries, thank you, Patrick. So as mentioned, Green Button Go Scheduler is what powers the C.STATION. So if you've used Green Button Go before, it's the same software you know and love. If not, we'll go through a brief walkthrough of the software here. So one of the key features and part of the design philosophy is this intuitive graphical user interface. So in the video here, you see a work cell being assembled in the software. It's from that left-hand column there, you would just drag and drop instruments into your work cell to build it in the software. And then here on the process tab, this is where you would actually go about building your workflows. And again, so any instrument commands available would show up on the left-hand side there, and you just drag them into your plate process, the actual method you want to execute. So we'd like to say, if you can talk through your method, your workflow, you can build it here within the software. It's that easy, just drag and drop, low code, no code. As we move on here, we'll see the schedule tab. So there is a basic scheduler included out of the box. A user can walk up and choose a date and time and the assay they'd like to run at a given point. Say I want to run it overnight when no one's in the lab. The Green Button Go will execute the run at that point in time. Finally here, as we come to the Run tab, this is what a user would typically interact with during a run. We'll see on the left-hand side there, instruments are turning green when they're in use. And then if there's an error or something happens, it would turn red, of course. Then on the right-hand side there, you see a live Gantt chart being built out during the run, so a user can see exactly where a plate has been or a piece of labware, so they can know exactly what's happening on the system. Just want to mention briefly, we haven't touched the Advanced tab yet. This is where you would really get into the customization of your workflow. But for simple runs, and if it's not needed for your workflow, you really don't even have to go in there. So what powers the C.STATION exactly is the customizability of Green Button Go. So this is the Advanced tab. This is where you would set up custom variables, set up conditional branching or loops, that sort of thing. What we see here is an example of how to build a user screen, and still it's that same drag and drop philosophy. So I've dragged in an image, I've dragged in user input box there for asking the user whether these plates will be sealed or not. We can easily assign that value to a variable, capture that information to use downstream, and make the workflow as dynamic as it needs to be. And so what do we see here with the C.STATION? So using these tools that I've just shown you, C.STATION has built a really great user experience and user interface for managing adherent and suspended cells. So if we can play the video, we'd like to show you an example of what that looks like. There we go. Thank you. See the video going now. So you would start a new campaign, give it a name, enter any information, a description there if like. Choose no tracking or tracking, as Patrick has mentioned before. So you have the option here of suspension versus adherence cells. And then depending on the selection, we see adherence cells here. You get some contextual parameters you can input. Watch with PBS, for example. You can choose the labware and the number of plates as well on that screen. And then as far as scheduling and calendaring the campaign, you can choose exactly which assays you want to run on any given day. So which work steps, whether it be liquid transfers, clonal transfers, or any other assays like plate imaging runs, for example. And choose exactly when those need to execute and if they want to start on day 0 or some future date and time. So once all these values are input, if there are any target plate labwares that need to be assigned, you'll see those here, and the user has that option. Now this screen is really cool. There's a lot of options that can be input here. So you can see a deck view can be toggled on and off to give a nice visual representation of what's going on. But the user really has full control over all the liquid handling and transfer parameters. So you'll see options for volumes, tip sizes, any aspiration and dispense parameters that need to be input. User really has full control over all of that. And what's really cool as well is that there's a validation check that happens with all these parameters. So if there's anything that doesn't quite match up, that might cause an issue downstream, the user can be warned about that and given the option to go back and correct that. And we'll see an example of that in just a moment. That screen right there, warning the user that there may be something they need to address to try to prevent any downstream issues before the campaign gets saved and scheduled. As we go through here, we'll see plates populated in the storage hotels. And then finally here on the calendar screen, we see those runs have been populated on the calendar, and then green button go will execute those runs at the given time. And so what happens if we need to edit a run once it's already been made, or edit a campaign after it's already been set up? So through the same great user interface, the same user experience, instead of new campaign, they would simply select browse campaigns and be given a list of all the campaigns that are active at that moment. They can choose the one that they need to edit, and then that edit plates button down at the bottom. You're presented all the information in this table format here, and you'll see the user can go in and actually edit right in this box, make any changes that are necessary, and save those back to the campaign. All right, there we go. Finally changed on my end, sorry. So what if you need to reschedule or adjust any of those assays that have been calendared out previously? So again, through the same user interface, I don't see the video playing on my end, but talk through it. Okay, here we go. Awesome. So again, the same interface. You go choose browse campaigns. You can see the one you need to make an edit on. In this case, you'll hit edit schedule down at the bottom right, and you'll have this scheduling function again to go back and choose exactly what needs to be done. So again, it's through the same interface. And we try to make it or CYTENA rather, has made it really easy for the user to go back and make any changes once these campaigns have been set up. So any target plate information that needs to be captured would be done there. And again, this very powerful full control screen of all the parameters is sent to the user again to make any edits or changes that are necessary. And you'll see now on the calendar, these runs that were just edited are now starting on day 3 versus day 0. But yeah, just summing up the Biosero portion here. So I'd like to say that we can build automated platforms using the GBG scheduling tool from very simple work cells with say only 1 to 2 connected devices up to much larger work cells like maybe in the bottom left and bottom right portions of your screen there with many integrated devices, even up to the biofactory level with multiple work cells connected by a transportation system like magnetic track, a mobile robot solution, for example. All those platforms are possible and enabled through our massive device driver library of now over 400 drivers. So with that, I'll now turn it back over to my colleague, Patrick, to walk you through some examples.
Yep. So thank you, Dustin. Yeah, I wanna get closer to the end of the webinar, showing you after a lot of technical software focused information about how does all of this look in reality. So on the C.STATION, in the end, from a hardware and technical perspective, there are 2 routes that one can go, which is a biosafety class 2 class 1 C.STATION and a biosafety class 2 C.STATION, where the first one is ensuring product safety, and the second one is ensuring product and user safety from a biological safety perspective. This actually compiles down to 3 main configurations of the C.STATION we offer. As mentioned, the cool thing about the C.STATION is it is a pre-configured work cell, which means not so much thought has to go into actually building it up, but there is already configurations targeting specific applications. And these are the 3 of them you can see on the bottom. The C.STATION suspension biosafety level 1 does target a monoclonal antibody production workflow. The C.STATION suspension biosafety level 2 targets a viral vector production workflow, and the C.STATION adherent safety level 2 targets cell therapy manufacturing. For the first 2 of these, we also offer a fat batch assay option. This is pretty much only usable in suspension cell workflows, and it provides another piece of information for clone selection at the end of the whole workflow, as one will get an impression how the clones would behave in the bioreactor after they exited the C.STATION. I want to continue with some case examples exactly around these 3 target application areas we see as mainly areas the C.STATION can be used in. First one being monoclonal antibody production workflows. So this is around a suspension cell workflow based on a transfected mammalian cell line. Classically, this would be CHO cells, can also be HEC cells. Basically, anything that is producing monoclonal antibodies can be handled in a safety level 1 environment and a suspension cell line. The C.STATION for that case it's designed to be medium-sized with a total processing capacity of 384 well plates, respectively around 11,000 clones. And usually individual projects take around 30 days from single cell dispensing to top 24 clones selected for biobanking. There is the ability to run multiple projects in parallel. Usually projects would be sized around 8 384 well plates, and then multiple of these can be run in parallel. As said, the maximum processing capacity being 30 plates. The device looks like this. As said, purely focused around suspension cell workflows. The total incubation capacity is actually 60 plates. You had me mention it's 30 plates that would be processed. This is due to the fact that target plates always have to be pre-warmed in the incubators, so cells don't hit cold media. Yeah, essentially the total incubation capacity is halved. And usually here selections would be done based on growth and titer. As I mentioned, the F-Quant kit is available through CYTENA and is fully supported on the C.STATION. Additionally, there's an option to use a fat batch module here. This reduces the incubation capacity to 44 plates because deep well plates take up more space and they would be shaken at the end of the workflow. Talking about the workflow, I'm only going to go briefly over this just so you get an impression on how our standard workflows look and our approach to this is. So for each of the case examples, we do have a workflow in mind that in our regard makes more sense, let's say. But as you've seen the scheduling feature that the C.STATION offers, these workflows can be adapted on the fly. Let's say clones aren't ready for picking, just delay it a few days. And then here you can also see where the fat batch module comes into play. After day 13, plates are split into 2 branches, where on one of the branches the evaluation happens, and these results are circled back into the main branch, and picking events are done based on this information. The second example I want to talk about are iPSC workflows. As I already mentioned, cell therapy workflows. So here we are mainly talking about adherent workflows. The C.STATION does or is fully compatible to adherent cells. Similarly, this is designed to be processor around the same processing capacity. Usually here we have a few weeks between the single cell dispensing event to top clones selected for upscaling in smaller bioreactors. Additionally here is the ability to run multiple projects in parallel. Worth mentioning, running multiple projects in parallel. Here we rely mainly on the scheduling feature you saw on Green Button Go, which helps us putting processes into places which make most sense to have the best productivity. For example, having imaging events rather in the night because they wouldn't need user attention, while anything that would require user attention can be set to be scheduled during the day. So again, well, here's an actual photo of one of these devices made for an adherent cell workflow for iPS cell line production of human donor cells. The total capacity here again is 60 plates, but then here we use a safety level 2 enclosure, which both ensures user and product safety. This version of the C.STATION is also able to be placed in a GMP environment. And then here you can see an exemplary workflow of cell therapy manufacturing done in the C.STATION. This is relatively straightforward compared to the fat batch assay. It's basically evaluating clones and scaling them up continuously. Worth mentioning here, there's the option to coat plates if required. Adherent cell lines usually, or in many cases like that. So there is the option to do that. And then here you can also see there is plates leaving the C.STATION for external assay. In case, as mentioned, there is anything that can't be done within the C.STATION, it can be done externally, and the results are fed back into the C.STATION and can be used to evaluate the clones. The third case example, third main application area, viral vector workflows. Here again, we usually have suspension cells, which would be HEC or SF9 cell lines. I think there's a mistake on the slide. Never mind. The cell lines are correct. C.STATION incubation capacity or processing capacity is roughly similar. Keep in mind, suspension cell lines usually run through processes quicker because they do not have to be dissociated at clone transfer events. Here again, there's the ability to generate sample plates using external assays to determine quantity and quality of vectors and feed back these results to the C.STATION. And again, obviously, no change to being able to run multiple projects in parallel on this type of C.STATION. Next slide, please. So here is a eerie photo of one of these C.STATIONs. Similarly, safety level 2 enclosure. So both product and user safety is ensured. Incubators in this case are placed outside of the device to prevent heat buildup within it. And then here, as already mentioned, targeting viral vector production, similar incubation capacity, selection based on growth and titer, while titer here is usually more external. So this is how an exemplary workflow for this application can look. We are using can make use of the fat batch version here too. So once deep well plate stage is reached, let's say within a project, the incubator where the plates are stored is switched and the plates are shaken. And then again, we use a secondary branch where external assays are done and the results are fed back to the main branch where the actual picking event happens. Yeah, leaving you with the best clones of the ones the project has been started with. So here, well, we're already coming to the end. I want to give you a brief summary. As said, the C.STATION being a streamlined automation solution for cell line development purposes. It's fully integrated and user-friendly. As you saw, one would only interact with Green Button Go, which is already easy enough by itself. But on top, we put our own UI and enhanced it with the ability to talk to the clonal data services and C Studio in the end. Then we have at the C.STATION, since it's pre-configured, it is pretty straightforward to do so. Once usually you would know what you want to do with it. So we have configurations for that available. That makes us typically having a timeline of less than 6 months from sales order in to the actual project being realized. Worth pointing out, again, the whole data management, traceability, the data integrity, supporting any GMP or CFI 11 compliance features. And then, ending it with the device being fully configured to the main target workflows, monoclonal antibody production, viral vector production, or cell therapy manufacturing.
Thanks, everybody.